Hello, everyone. Yeah, welcome to our next cool talk. And here are we today to talk about Airflow. I'm Nikolai Markov. I'll be like an expert on this talk today. And with me here is an amazing guy, Ash Berlin-Taylor from Astronomer, director of Airflow Engineering, and that's how you that's how it's actually called. So, well, hello, Ash.
Hi there. Thanks for having me. I'm excited to be here today.
Oh, pleasure is all ours. So, how's your day today? So,
It's good. It's a bit chilly to here today, and I've got construction going on in my house, so I have no heating. But apart from that, everything's good.
well, so I don't know, like, for how long you've been working on Airflow? Like several years now, right? Or
yeah, I started working on Airflow in 2017, so it's coming up for 4 years. I've been working on it. I got started because my team at the time I just joined a small data engineering team, and I was doing DevOps and just kind of AWS automation, and like come and deploy Airflow. That's cool, right? There's an AWS instance. Yada yada yada. You know, that's what I did. And then kind of one thing led to the next. I started fixing bugs in Airflow for my team and helping them write DAGs and kind of adding some cool features and custom operators and things like that. And then got invited to join the PMC or EPMC modeling project management committee when we were still incubating in 2018. And then kind of been involved since the summer of January 2017.
nice. Yeah. So this is, ladies and gentlemen, how you get to open source. So
it's be privileged enough to work in a place that will let you contribute to it on company time is definitely the easiest way of doing it. Otherwise, you have to kind of spend your spare time doing it. Yeah.
Okay. And are you also contributing to some other projects? So this is like your main thing?
Not really. I kind of contribute to the odd repo here and there, but my day to day is working on Apache Airflow and nothing else. I do odd pull requests here and there for various Python modules, and I've got a few small modules, but no, I don't contribute to anything else at the moment. Just Airflow.
Okay. Yeah, and is Python the main language that you use, or also you write like?
It is now. I have done various things, mostly all dynamic languages. I started out using Perl, which immediately dates me, and then a bit of Ruby, Python, a bit of Go here and there. So yeah, definitely kind of a polyglot, but Python is my main language and has been for about 8 years now.
And you think like Python is the best choice for writing something like Airflow, right? Or maybe I know it's a tricky question.
It's like if I was writing it from scratch, would I write it in Airflow? So write Airflow in Python. One of the advantage of writing it in Python is that data scientists mostly use Python these days. Therefore, you can get more contributions from your users. Whereas if you wrote it in something like Go or Rust, which might be what people would use now, and you've got one language for the people using it and another language for the people writing it. There's very little scope for kind of drive-by contributions. So yes, I think Python is still the right tool for the job.
Okay, yeah, that sounds great. I know it's, to me it always is. I saw Airflow like this kind of factorial game where you just connect different parts of your infrastructure, converting the data, putting it to some other place for processing, and so on and so forth. So and currently, I think this is like one of the main projects, like the golden standards of how to do workflow management inside data science world. So it's really nice to have you here and to be able to ask your some tricky questions about that.
Yeah, please. Looking forward to them.
Okay, so let me pass the microphone to you, and what do you think about starting?
Yeah, sounds good.
Okay.
Thank you. So yes, I'm here today to talk about Apache 2.3 and beyond. Like, where does the future lie for Airflow? First, let me start with kind of who am I and what do I do? So, as Nicola said, my name is Ash Berlin Taylor. I am a member of the PMC, the Apache Airflow project, which is what every other project would probably call a core contributor, but Apache Software Foundation projects have their own terms for this. And I am also director of Airflow engineering at astronomer.io. It's a very fancy title to say I kind of run the open source Airflow engineering team. So, kind of before I can say where we're going, it's probably useful to talk about how did we get here. So, Apache Airflow grew out of Airbnb at the tail end of 2014. Kind of open source pretty much from developed in the open. I think it was open sourced as well. Kind of from day one. By 2016, it had been kind of incubating in Apache. So Apache projects, kind of new projects, they go through this incubation phase to show they have appropriate governance and their healthy community and things like that. So that lasted for us until 2018. Yeah, and Airflow grew up in a very much an ETL world. That was kind of where it started. So kind of early 2015, kind of the primacy of Hadoop and Spark, they were still kind of common, if not the cutting edge at that point. But yeah, so it's kind of like Airflow has evolved and had a lot of different contributors over the years. And to some extent, there was some technical debt laid down because there were lots of kind of features tacked on and added on over time that maybe weren't quite designed, or no one had the time to sit back and go, hey, how do we do this? What's the best way of writing this? Airflow 2.0, which was released December last year, we kind of tackled one of those big ones, which was the scheduler performance. So the scheduler was kind of, you were only supposed to run one, and it wasn't that performant. So we tackled that and kind of rewrote large chunks of it to make it more performant. Some workloads we got 10 to 100 times speed up, which was kind of almost embarrassing how slow it was. And then we, and you can also run more than one. Anyway, that was just kind of to say Airflow started out in an ETL kind of daily batch processing kind of workload. So Airflow 2.2, all going well, it will be released in about 50 minutes time. So what are some of the kind of the new features in 2.2? So there are two big features. The first one is customizable schedules. So a brief side, AIP, Airflow Improvement Proposal. If someone wants to make a kind of a big change or a structural or architectural change to Airflow, we as a project have kind of this relatively lightweight process called AIPs, which is someone writes up a proposal, says kind of what it's trying to achieve, what the outcomes will be, and then we as a kind of development community say yes or no. So AIP 39 was to make scheduling in Airflow more powerful. So rather than just a scheduler interval, you can now replace it with timetables. Why did we do this? Two reasons, as I say, to make it more powerful, and also the execution date concept is just confusing to everyone. So we got rid of it. It's still there. It's not going to go away entirely. We're quite rigid about maintaining backwards compatibility between major versions. So if it works in any version of 2, it will continue working up until we get to 3.0. So we follow Semver. But yes, execution date has been deprecated and replaced with logical date, which is just the same value but with a different name, to kind of remove the mental association of execution. And then data interval start and data interval end. So that kind of says, here is a bracket of time that this task should look at. There's much more to it than this. You can basically have pluggable timetables, so you could run on almost any kind of schedule you want. So, for instance, you might want a trading hours. So, if you're processing financial data, you want to run your DAG after every trading day. And sometimes, there are holidays. So expressing that in a schedule interval or a cron expression is difficult. And you then have to put some kind of check for, is this a holiday? Should I skip the DAG? Whereas now you can just go create this class once and then reuse it. So that's one. That's AIP 39. The next one is AIP 40, which is deferrable or async operators. So in Airflow 2.0, there was a feature added by Airbnb, the team who originally kind of open sourced Airflow, called Smart Sensor. So Airflow looked at their cluster, their Airflow cluster. They probably still have one of the largest Airflow clusters in the world, at least that I know of, approaching a couple 100,000 tasks a day kind of scale. Smart sensors were basically a way to reduce the load of sensors. So Airbnb had something like 60 to 70% of their tasks at any one time were sensors that were just sat there waiting for something else to complete, but taking up space on the Airflow cluster. I think their use cases were Hive or HDFS, basically waiting for this file to appear. But many kind of cloud operators, so BigQuery or EMR or all that kind of stuff, they all follow we'll submit a request and then every 30 seconds we'll poll to check the status, which is very wasteful to use a whole executor slot to make one network request and then sleep. So deferrable tasks was a generalization of smart sensors that applies to more than just sensors. So any task can defer itself and go run this code in an async loop. So it uses kind of Python 3.7 async IO. And I won't get into all the details here because that's kind of not the subject of this talk. If you want to find out more, check out the docs for 2.2 when it's released in about an hour, or go check out the talks from Andrew Godwin at the Airflow Summit. So yes, he will. Anyway, the Airflow triggerer can run. It's an async IO event loop. It can run hundreds, if not thousands, of concurrent tasks at the same time. It's kind of cooperative threading, multiprocessing. So you can cover all those tasks and run them down to a single process. That's just kind of much better. To kind of give you a flavor of what these two things can do, these two AIPs, if you can combine them together. So on a DAG, you can provide a timetable. This example actually came up from someone asking in the Airflow Slack. This was a question asked by an astronomer, not me, not someone who works for astronomer.io, but someone who looks at the stars. They basically hey, we want to run this DAG at sunset. Can we do that? And it's not now, but it's coming. So this was, I just kind of, it always amuses me. But yeah, so kind of, you can provide a timetable argument. This class doesn't exist. I've made it up. You can kind of guess at what it does, which is, at dusk when it's starting to get dark, you run this, you can open the doors. And then down at the last line, we have the time sensor async. So that's a time-based sensor, but it's asynchronous. So rather than blocking a worker slot, it just kind of gets deferred, runs as a coroutine inside the triggerer, and then when its condition is passed, it goes back on. So yeah, that's just kind of finding the two AIP 39 and 40. These are both kind of powerful features in our own right, and definitely open up some exciting possibilities of what we can do with Airflow in the future. So yeah, that was 2.2. If there's any kind of questions about those, now might be a good time for those.
Yeah. Hey, I've been listening to you. So let me ask this: if I understand this correctly, for now it won't be like like a spin lock, like us waiting on an event, but we are actually receiving that event from the outside inside event loop, and then we use all the modern stuff with async IO to actually react to it. Is that correct?
Yeah, that's pretty close. So it kind of depends on what your deferred operator does. So it might just be I'll make a network request and check the status and then go back. But obviously, then network requests can also be done using async IO, so those don't block things either. But yeah, no, definitely, it's combining a lot of the sleeping and network request paths into one place and running them all much more efficiently.
So it's a bit similar to, say, like AWS Lambda, right? So when the file appears,
yeah.
Okay.
Conceptually,
sounds awesome. And any other plans to bring more async features there? I mean, obviously this is like the most important one, but
yeah, absolutely. This is kind of like the first use of async IO inside Airflow core. But now I'll cover a bit of this later. But yes, lots of plans. Like, hey, now we've got async, we can start to do a lot of cool and exciting things.
Perfect. Yeah, thank you. Please go on.
Cool. So, what is a roadmap? Silly question, but in kind of software project, a roadmap it's a lie. All roadmaps are lies, but hopefully it's a useful lie. So, kind of what I'm going to present over the next 42 minutes will be my vision for what Airflow could become and how we might get there. It's not going to be exactly what we do. It's not necessarily going to be the order in which we do it. But here's an inspirational vision. Here's what we could build in Airflow. And this is just my opinion. This is not this is not blessed by the Airflow PMC. This is just here's my vision. And obviously, I'm going to be working on some of these, so some of these are going to happen. But this is it's just kind of like come along for the ride, and hopefully, this inspires some of you to go like, yeah, Airflow, I like that. I really want to work on that. So, some kind of core tenets behind the roadmap. Airflow DAGs should be a joy to write. It should be clear to write, it should be easy to write, and it should be easy to read. That one perhaps more important than easy to write, because reading code is harder than writing code. I want Airflow to be the go-to data orchestrator for every job. If you have a data problem, data workflow, I want the answer to just be, let's just use Airflow. We're not there yet. There's lots of kind of special niches or kind of special cases where Airflow might not be the best tool for the job, but I want to get there. And Airflow should be easier to operate confidently. There's still too many cases where sometimes Airflow just runs a little bit weird, and you don't quite know why your tasks aren't running. But that shouldn't be the case. It should be, transparent about what it's doing. It should be better observability, better metrics, kind of things like that. They are all at once, just so you can kind of see them as a single slide. Making DAGs a joy to write. It should be easy to read the DAGs too. Airflow should be the go-to orchestrator for every job. It should just be the default. It should be, I've got a data workflow, I'll just run it in Airflow. That's what I want. Clearly, I'm biased. I work on Airflow for a living. But I think Airflow is pretty close to that already, so let's fix it to make it better. And then, Airflow should be easier to operate. This is particularly me with my DevOps hat on. where Airflow, it mostly works now. It's getting better over time, but I'm not happy with it yet. There's still lots of things where I would like it to be better. So I've covered 2.2, and I've given you kind of an idea, some grounding. What is going to be in Airflow 2.3, 2.4, the kind of next, let's say 6 to 9 months? First up, dynamic DAGs. So right now, the support for dynamic DAGs in Airflow is not great. There is more than one occasion where things are a little bit weird, and you, as a DAG author, have to work around limitations in Airflow. And yeah, like dynamic DAGs are an important part of kind of the Airflow toolbox that are not well served right now. You can do them, but you have to be, there's caveats to be aware of, and you have to just kind of, you can't do it as natively as you want. So to take a first example, something that people new to Airflow kind of often ask, which is like, hey, I've got all these files in S3. I'd like to run one file per task. Is there any way of doing that? And right now, the answer is no. But we're very close to starting an AIP around this, a feature we have called mapped tasks. So kind of, if you're at all familiar with functional programming in Python, map and partial should be familiar to you. But essentially what this pseudo DAG will do is, it gets a list of files in S3, and then, you'll end up with n copies of this file processor operator once for each file. So kind of, you can, in that regard, you can think of mapped tasks. They're a template that kind of gets stamped out at runtime and replaced with n task instances. Like, again, nothing I'm saying here is like, this is going to be the API. We haven't fully finished designing it or working out the implications yet. But yeah, you'd be able to map over XCOM results, so kind of store over that. Variables, so if you store something in the Airflow kind of variable concept, you can do that, or maybe even it makes sense to do static literals and have that work. And obviously, kind of like the UI will need to handle it. So this might be kind of how we'll show it. So you kind of like, wait for S3, and then you can kind of see, oh, there's multiple process file operators, and we kind of expand it out. That's kind of one, which is, it's kind of like not quite a full for loop. But yeah, being able to expand tasks and run multiple copies at runtime based on previous tasks or external state or something like that is definitely kind of a important feature that's missing in Airflow. That opens up a huge number of kind of options to make your DAG be closer to how you would just write it natively without having to work around Airflow. And then the other thing we're thinking about with dynamic DAGs is parameterized DAGs. So, for instance, this is kind of defining a DAG using the TaskFlow API, so the @DAG decorator. And it takes two parameters. So you've got markets, the list of strings, and then campaigns, which is, I don't know, some mapping, some dictionary. It would be nice if there was some way in the Airflow UI, or maybe in the DAG file itself, to go, here is my list of markets, here is my list of campaigns, run this DAG once for all of them, but kind of treat them all as the same DAG. Rather than right now, you would have to make a DAG factory and then create n copies of the DAG and things like that. But this is just kind of taking that to removing that need to having to do it in Python code, because there is being able to do it via the Airflow UI. So every time it runs, it goes, hey, what are the parameter sets I need? Let me create one DAG run for each of those. Being able to do that via the UI, for some people, will be nice. Some people will not like that, and they like to have everything done via Git. Great, I love that too. But we're trying to make Airflow work for multiple people. So there's that. Part of making this work will also be we will need the ability to have more than one DAG run for the same date. So right now, you can only have a single, for one DAG, you can have one run a date. So DAG ID, execution date is a unique pair in the database. To make this work, we will need to remove that uniqueness constraint. This also opens up some interesting possibilities for kind of machine learning. Kind of like, again, same sort of thing, parameterized, but if you have, if you want to do an A/B test or kind of some kind of multiple models or multiple parameter sets, hyperparameter tuning, that kind of thing in parallel. Once we've got this ability in Airflow to have multiple DAGs for the same date, you can then start to do it. So yeah, maybe you can do, again, maybe adding more capabilities to Airflow. So yeah, parameterized DAGs. That's kind of like, hey, here's some cool features. Other things that we're thinking of for the kind of the near term, something like an Airflow CTL. So if you're at all familiar with Kubernetes, you have kubectl or kubectl, however you want to pronounce it. I don't like kubectl, but there we go. But yes, making it so that you can use the Airflow CLI to speak to a remote cluster, remote Airflow instance. There'll be a few commands that you can't use that way. Most likely, kind of anything dealing with the database, but everything else should be able to use the API and kind of like be able to manage almost all the state locally or point at a remote cluster. We'll need to expand upon the API. So in 2.0, we added a REST API that's kind of fully specified. We've got an open API specification. Used to be called Swagger, if that means anything to you. So we'll have to add many more endpoints to make that work. But I think this is it'll be a nice feature to have so that, if you've got your cluster on AWS or wherever, you can run Airflow CTL on your laptop and double check the state of things like that. Another thing that we need to look at soon is not trusting our own workers, which possibly sounds strange, but right now, each Airflow worker has complete, unfettered write access to the database. That includes code running inside your DAGs. So until you do this, until you have untrusted workers, you can't really segregate and enforce a permission model on connection. For instance, if you have, this write database should only be able to access from the ML ops team, but the business analyst team should only be able to have a read-only connection to it. Right now, you can't enforce that. You can encourage it, but if someone messes up or things like that, you can't enforce it. So we should be able to do that. You should be able to assign RBAC role-based access control permissions on a connection. But for that to work, the tasks, the workers need to not have write access to the database. They should go via an API server to report the status and to give me connections. Therefore, the API server can enforce, oh, hey, this is coming from DAG X. It has permission access to this. I think that's going to be an interesting one for kind of some big customers and perhaps anyone working in a regulated environment. So perhaps a little one, but making it easier to kind of run callback and like lifecycle hooks. It should be possible to just say something almost as simple as this, where you kind of like, on failure, send a Slack message. Yeah, it's just right now you have to customize this yourself, and it's almost just a hole in the Airflow API that something so common as doing this, you have to kind of write a bit of code yourself to do it. Like there's a Slack hook or a Slack operator, and you can write a custom method. but why isn't it this simple? It should be almost this. So just kind of expanding upon the kind of failure callbacks, and that probably applies to all the callbacks, and perhaps adding more callbacks for different kind of state mechanisms, so that you can do things at a cluster level, or you can make it easier to plug into Airflow and capture state transitions. I know there are some lineage projects which are looking to be able to do something like this. And then the other thing we are looking at adding is a better Cross-DAG story. Right now, the only kind of way of doing anything Cross-DAG is with the external task sensor or a trigger DAG run operator. There's no nice way of doing that with that. It's always a bit clunky. So kind of, there's two related things that make kind of like that make Cross-DAGs nice. The first of which is event trigger DAGs. So kind of going back to AIP 39, where it was the kind of timetable. That's still very much run this DAG on a schedule. It's just the schedule may be irregular. So, it's kind of computable up front, and the timetable class can tell Airflow, here is the next time to run this DAG. Event trigger DAGs it will likely build upon the framework added in the deferrable operators. And it will, there's kind of multiple different flavors this could be. This could be, I'm going to listen on a Kafka stream, and when I see a message, I'm going to trigger a DAG. Essentially, when it kind of boils down to it, it will be something that runs inside the async loop, inside the Airflow triggerer, and instead of resuming a task, it will create a DAG run. But we need to come up with a nice kind of nice interface for that, which haven't started thinking about yet, but it's definitely there. The other side of Cross-DAG dependencies, better Cross-DAG story, is a data object. So right now, Airflow doesn't know what the tasks are doing. Essentially, as far as Airflow is concerned, the task is just sleeping. Like it's Airflow is like, hey, I'm going to run this thing. My job is done here. Which is great. It means you can do whatever you want in Airflow. I've once thought about how I would run Airflow's own CI system inside Airflow. Like event DAG, someone pushes the Git, that sends a webhook, that triggers the DAG. We got a big task matrix. Each one of those should be a task, and task mapping and stuff like that. I've worked out how to do it. I'm never going to, because I don't want to write a CI system. But anyway, you could do it. And Airflow, it doesn't care what it's running. But if Airflow is told about what it's running, or has some way of introspecting what it's running, you can do a lot. We can do a lot more in Airflow to make it richer, to make it nicer. So we are exploring the concept of a data object, which might be built on top of lineage. It might not. But one of the things you could do is you could have data-based scheduling rather than time-based scheduling. You can have data-based. So here's a small example. Sorry for the large code, or the large amount of code on this slide, I should say. This is kind of a typical-ish EMR DAG. Creates a cluster and then runs a step in it. But it's got one change at the moment. It's got an outlet, which is So Outlet is the kind of the existing lineage interface in Airflow. And then we've got this data object. So kind of data object has a URI or a kind of identifier, is essentially an opaque string. So it's all kind of fairly normal at this point. But you could do something like this. You can use it as a data reference. And what this would do, give or take, this kind of schedule on result. Whenever this data object is changed, the downstream DAG is triggered. That kind of opens up to a lot more interesting options, rather than like, I need to run some time, and I know that one runs every hour, so I'll run this later, or external task sensor, or kind of external, rather than having to wait and run it on the same schedule and just go, okay, I'll wait until that DAG is done. You can say, no, I just run whenever that DAG is done. This makes the kind of the relationship between DAGs a lot more explicit, because like this is what you're trying to encode, but you've had to work around the absence of things in Airflow. Don't read too much into this this API. This is just me sketching out some code. It may look nothing like this by the time it kind of sees the light of day. The other thing that a data object could do is you could have automatic cleanup. You can have lifetimes to your data. So if you have something like this, back to the previous slide, where you have kind of a temporary thing, you could add, say, like this data object has a lifetime of the DAG. So if you used it in multiple tasks, it's sort of kind of an intermediary thing, and then when the result is created, if you tell Airflow about it, it could automatically delete it for you and clean it up at the end, rather than having to make a task to do the cleanup and then worry about all the different trigger rules and stuff. You could just kind of, Airflow can take care of it. Again, being a little bit more explicit, less kind of working around Airflow and Airflow doing things for you. This is good. Yeah, this is really exciting to me. I guess the other thing we could do, earlier I mentioned kind of if you're doing A/B testing or multiple model kind of hyper parameter tuning of your ML models. If Airflow knows or is told a bit about it, then you can display metrics, information about each of these different runs, about this data inside Airflow. So you could have fitness scores for, you've got 10 different runs, different parameters for the same DAG, and you're just trying to find them out. You could have fitness scores graphed in Airflow. So that's just kind of a simple example. Lots of things like that once we know what the task is doing and know something about the data it has produced, we can do some really exciting features in Airflow. That was kind of the next. I said 6 to 9 months, but in practice that may end up being 18 months to develop it. We'll have to see. So what else is coming down the pipeline? What else have we got kind of that we're working on? So DAG versioning. Right now, as I'm sure you are aware if you've kind of used Airflow, if you change the DAG code mid-run, it kind of just takes effect immediately. Which sometimes, I guess, rarely good, but more often than not, it's confusing, and you'd like a run to be fixed. So the version of the DAG, the version of your tasks doesn't change while a DAG run is in progress. So we want to work on that to make sure that it's just kind of, once a run starts, frozen. It always runs the same. And also, the UI is useful in historic cases, because right now, if you change the DAG run, then the the UI is just wrong. The UI always shows the graph, the latest DAG run, the latest structure, even if you go back and look at the DAG from 6 or 9 months ago. And yeah, you could change the DAG ID whenever you change the structure, but I don't like that. I think it would be nice if you like this DAG, it's grown over time, but it's the same DAG, same function, we're producing the same output, consuming the same input. So what we do is change, but let's show what actually happened. I go look at 6 months ago, I should see what actually happened then. Anything else is kind of almost clearly wrong. So like making the UI right is kind of almost the easier of these two. Making the version of a DAG used for a single DAG run to be consistent is a little bit harder. Ties in with this easier DAG deployment. So right now, Airflow is completely unopinionated about how to get your DAGs there. So Airflow needs DAG files on disk. And it's either you kind of put them there, you rsync them in, you bake them into the image, or you run a git sync sidecar or something like that, depending on how you are running Airflow. But it leaves like how you do that kind of almost entirely up to you. Which I mean, it makes sense because it's easy from a project point of view to be unopinionated, but because we're unopinionated about that, it means we can't do the previous thing of fixed versions because the code's changed, and we can't do anything about that. If the code's changed, the task reads the file on disk and executes it. So there's a kind of proposal of various different proposals. We haven't kind of worked out what it's going to look like, but DAG fetchers or kind of DAG manifests, so that Airflow can get the version of a DAG from some external store, whether that's a Docker image or a version S3 bucket, GCS bucket, or even a Git repo. But if we can get a fixed version of a DAG file, then we can make sure that all versions of the DAG run use it. And to do this, we kind of have to. I've said easy DAG deployment because it is, because you then don't have to worry about how you're doing it. You just go like, hey, here's my Git repo, or here's my S3 bucket, or whatever, or here's my Docker image, and this is the name. By doing that, we can, kind of tackle two problems there. We can do versioning, and we can do make DAG deployment easier, so that everyone doesn't have to make the same decision of, oh, which one of these mechanisms do I do? Streaming. So Airflow doesn't really support streaming right now. It kind of, if you try to run a task in Airflow that never finishes, yes, it will technically work, but it's not really what Airflow is designed to do. So yeah, I'd like to fix that. I think with the improvements to the scheduler in 2.0 to kind of like improve the performance, we're now much closer to be able to do micro batching. Again, kind of trigger that, combine that with the event-based DAGs I mentioned, so you can possibly. I wouldn't say you should write, a consumer in Airflow yet, but I want us to get there. That's what my goal is, to make it possible to do that. And also better support for long-running jobs. So if you didn't want to kind of do the micro batch approach, but something more typical of, hey, kick off this long-running process, and if it falls over, start it again. Something kind of a process supervisor almost at that point, which Airflow already does. So yeah, just kind of some better support for that. Now I've got an ask here. I do not and have never written any streaming workloads. It's not what I do. So if you have done streaming in the past and use Airflow now, or are doing streaming currently, use Airflow in the past. Let me know. Speak to me. Tell me what you'd like. Help me design better streaming support into Airflow. And yeah, kind of better. The other kind of thing on my roadmap, on my list, is better support for streaming jobs. Streaming jobs, done that. Better support for machine learning. So this kind of comes under multiple categories. Some of it is the things I've already mentioned about multiple DAG runs for a given date, but some of it would also be better integration with the existing machine learning tools. Airflow doesn't need to and shouldn't try to do everything, but we should integrate with the things that already do a good job of that. So MLflow, maybe we kind of tie that into the Airflow UI, or have a better integration with that. Model hosting, so maybe they make it a nice easy way to host a model, and maybe kind of promote models when you built a model, you can test it out, and then yes, that one gets blessed and approved, and then already tied into the model hosting, and maybe even kind of automatic publishing of here's a fitness criteria. If the next one is better, and we know the current fitness score, we just run one. If it has a better fitness, it could be automatically promoted, and then answering tasks will automatically use that model instead of the previous one. Again, I lasted. Well, when I last did machine learning, it wasn't even called machine learning, which kind of says how old it was. So, same ask as for streaming, which is, if you use machine learning, tell me what you'd like Airflow to do better. Help me build the features that makes Airflow better for you. Because I don't do machine learning day to day. I don't know what the exact problems are. So I'm kind of I'd have to guess, and if I guess, I'm going to get it wrong. So, like you will to tell me. And on that note, are there any questions? Oh, and of course, I should say before that, we are hiring, of course. Python developers, Node.js, SRE, WebOps, everything else. Even if there's not a published job on that page, if you'd like to come and help us work on Airflow or any of the problems mentioned, speak to me. We've got jobs. We've got lots of jobs.
Okay. Yeah, thank you so much. I actually have I had one thought during your talk, during when you were talking about data object, and you also mentioned XComs. And I remember that one of the hot topics in data engineering right now is passing over the data frame between instances of various processes using, ideally using shared memory. So there is even a whole project dedicated to that. It's called Apache Airflow.
Yep.
My thought here is maybe you know something about it. Is there any discussion going about passing over some huge chunks of data between tasks using some kind of similar mechanism? So it would be, I know that we don't probably, it's not like we're converting Airflow into Dusk or into Spark into something, but I think it would be a nice thing to have. What do you think?
Yeah, absolutely. So yes, we want to make that better. We did a little bit of that with kind of pluggable XCOM backends, but that's not quite the full story. Yes, I've got lots of ideas and not enough time to write them or people to help me do it. So hence previous thing. But yeah, yes, using Dask, using Ray from Anyscale, same sort of thing as kind of Airflow, Arrow. Yes. And then also, I guess, kind of, you could maybe grow the Airflow scheduler to be kind of aware of data locality, of hey, this data is already on this node. I'll try and schedule the next task that needs the data on that same node. Yes, there's lots of things I want to do there. I don't have firm ideas. There's only so much space in my head to think of things. But yes, that would be a great feature to support Arrow, to support Dash, support Ray. I guess, yeah, it's an extension of the data object proposal. We're trying to flesh that one out now. It's kind of not fully formed in code yet. Like, we know the top level goals of it needs to do this, but we haven't kind of worked out the bottom layer of here's how you write it in the DAGs. We're still working on that one, but that's absolutely kind of shared memory and that kind of stuff of parsing large data frames is absolutely one of the things we want to work on with that feature.
Okay, yeah, sounds promising. Thank you. And we've probably been asked this question like 1,000 times already, but I personally always had this dilemma where on the one hand, I'm not that guy who really likes to program in YAML, but on the other hand, is like to me, always the graph of tasks without any dependence on what is in those tasks is kind of a declarative thing. So, and I know that there is new API in Airflow 2.0 with TaskFlow API. But can you please shed more light on future plans? Like, are there, will there be the way to specify a graph on, some kind of declaratively not using Python? Maybe YAML, maybe some other language. Maybe.
Yeah. Yes and no. So this might be the kind of thing where it never makes it into Airflow core, but it might be kind of an add-on project. So one of the changes we did, I think it first landed in 1.10.7, but it was kind of written for 2.0 and backported, was kind of DAG serialization. So right now, the scheduler and the web server don't operate on the actual DAG. They operate on a JSON representation of it, and it's only the task execution that needs the actual file. So kind of like we're halfway there already because we've got this JSON structure and it's a task name and some dependencies between it. So kind of like one of the things when we were working on that feature that we kind of were aware of was we should assume we're working in a world where you can submit a DAG representation over an API. So you could do Airflow submit DAG and you give it a YAML file, much like you can do kubectl apply. You could do Airflow submit DAG, and then kind of it pushes everything up. So it's not on my roadmap because I don't like writing YAML, but enabling that kind of workflow was definitely it's definitely in my mind when we were working on DAG serialization in the run up to Airflow 2. So yes, I definitely want to make it possible to support and kind of nicer to support natively rather than right now you basically have to write a DAG that reads the YAML file and it's all a little bit clunky. So yes, but I don't know when.
Okay. And what about like writing, for example, operators and some additional plugins in languages different than Python?
So Airflow can, it wouldn't have to be. It would have to be. You'd have to write a Python shim or a bit of declared boilerplate. Yes, so I guess you could have a YAML file going like these task parameters get mapped to this command, and then Airflow just runs a command. Because obviously, if it's Python, we've got to shell out to R or to this Java command or something. But yes, we could make it easier to find an external program, external language into Airflow without having to write a Python class to do it. Again, but that would probably be a good case for YAML or something like that. Here is a list of mappings of parameter name goes to this structure and things.
Well, I mean, Python already has quite a few cool instruments for integrating with other languages. Maybe maybe I'm just like, running too far here, and maybe Airflow doesn't really need to do anything specifically for that, because you can, just, as always, write, some C package and use it as a plugin.
Yeah, again, just kind of making it easy for people to do what they want with Airflow. That's my goal. If someone wants to do it with Airflow and it's not brief aside, one of the hardest things to do as a developer, as a maintainer of an open source project, is to say no to a feature request. So sometimes it might have to be like, yeah, that's a good feature request, but no, this doesn't belong in Airflow. Write a plugin and then you maintain that separately. This doesn't belong in Airflow. If I can, saying no is the hardest thing to do. And at some point, we can't accept every pull request because we have to maintain it when it comes to the end of the day. So.
Yeah, especially with such a large open source project.
Yeah, exactly.
And speaking of that, did you discuss? Probably you have, but like splitting maybe to some separate parts, like a scheduler separate.
Yeah, I mean, so we release things separately. So we now have the Airflow core, which is the scheduler, the web server, and the kind of the worker execution framework. That's released as one package. And then all of the providers, so all the hooks and the operators, with the exception of Bash, Python, and a few other little ones like that. So all the other providers are released separately. So there is Apache Airflow providers, Amazon Apache Airflow providers, MySQL, things like that. It's still all in a mono repo, but they are released separately, so we can have different release cadences for core and providers. We may change that in the future, but also yes, there's also there's a growing ecosystem of third-party providers. So kind of Great Expectations have their own Airflow provider, so we don't need to write that in core because the Great Expectations team are already doing a great job of maintaining that.
Okay, so thank you so much for coming to us today, and maybe there will be some more questions in discussion zone. You guys can join it through Zoom, as far as I understand, and we both will be here for some more time. I mean, there in that zone. So, okay, thank you very much, and see you.
Thank you very much. Bye-bye, everyone. See you in Zoom.